So good morning everyone. So today we are going to see about reactance diagram in power systems. So for the given power system network, we have to draw the reactance diagram for the calculation and analysis purpose. So how to draw this reactance diagram? So for the given network, you can see we have the generator and transformer T1, transformer T2, and I have a load as motor. So the ratings for the generator is given 11 kV, 3 MVA, X as 0.2 per unit, and transformer we have step-up transformer 11 by 128 kV, then 5 MVA, and X is 10%. So in terms of per unit, it is divided by 100. So X is equal to 0.1 per unit. And transmission line is given as J 100 ohms line reactance. Then T2 128 bar 12 kV. It's a step down transformer. Then 10 MVA transformer rating. Excess reactance is 15%. So in terms of per unit, X is equal to 0.15 per unit. Then we have the motor load 11 kV, 15 MVA, and X as 0.1 per unit. So we have the base MVA. It's given in the problem as base MVA as 10 MVA and base kV as 12 kilovolt. And assume it is in the generator side. So generator side is over here. So what's the thing is, you have to calculate kV base new on each section. So first you have to identify the section. So how to identify? So whenever there is a voltage changes, voltage rating changes, so there we have to assume a new kV base. So for example here it is 11 kV and here it is 11 kV. So section 1 and here it is changes to 128 kV. So section 2 and here it is changing from 128 to 12. So it is section 3. So I have 3 sections. So I have identified section 1, section 2 and section 3. Okay. So now you have to calculate the solution. The first thing is you have to draw the single line diagram and you have to represent all the values. So before getting into that, you have to calculate the kV base new on each section. So for example, it is given in the problem as kV base as 12 kV at generator side. So kV base section 1 kV base new is given as 12 kilovolt. Then section 2 kV base new you have to calculate. Section 2 you have to calculate. So what's your formula? kV base on HT side. So where you have to calculate? HT side of transformer 1. kV base of section 2 of T1. That is HT side. HT side of T1. So this is my HT side, this is LT side. Okay, a low tension side and high tension side. So it's a step-up transformer. I have to assume we have to calculate the new kV base on the HT side of transformer T1. So what's the formula? kV base on HT side of T1 is equal to kV base on LT side of T1 into voltage rating of HT side, voltage rating on HT side divided by voltage rating on LT side. Okay. So you have to calculate. So here kV base on HT side of transformer T1 is equal to kV base on LT side of T1 into voltage rating on HT side divided by voltage rating on LT side. So you have to substitute. What is kV base on LT side? So this is my LT side. What is the kV base here? It's given in the problem as 12. So 12 into voltage rating on HT side of transformer, it is 128. So 128 divided by kV voltage rating on LT side. So it is 11. So if you simplify this, you will get 140 volt. 140 kV. You can check it out. So we have found out what is the kV base on section 2. So now again the voltage changes here from here to here. So this transformer T2, it is step down transformer. So now you have to calculate section 3, what is the kV base on this LT side. So kV base on LT side of T2. So it's equal to kV base on HT side of T2 into voltage rating on LT side divided by voltage rating on HT side. Okay. So you have to substitute here. What is kV base on HT side? Here we have found out what is the new kV base. Right? So previous one 140 kV into voltage rating on LT side. It's 120. 12 by 128. So if you simplify this, it is 13.12 K. Next thing is you have to calculate for expire unit for each section. First you have to calculate for generator. So the X per unit for generator is equal to, the formula is X per unit volt into kV base volt divided by kV base mu square into MVA base nu divided by MVA base volt. Okay. So you have to substitute here. So what is your X per unit volt for generator? It's given in the problem 0.2 into kV base volt on this one. So kV base volt is given value, this 11 divided by kV base nu is 12 into MVA base nu. MVA base nu is 10 MVA divided by 3. If you simplify this, you will get X per unit nu as J0.56 per unit. Okay. So next thing is you have to calculate for transformer. We have calculated reactance for generator. Now you have to calculate for transformer T1. So what's your experiment here? Experiment nu. Formula, same formula. Experiment volt of transformer T1. Experiment volt is given in the problem. So it's 0.1 J 0.1 into kV base volt by kV base nu. kV base volt is here. kV base is 11. kV base new is what we have calculated in section 1, it is 12. 12 square into MVA base new is this one, MVA base is 10. MVA base old is given in the problem as 5. If you solve this, you will get as 0.168 per unit. This is for transformer 1. So here X per unit new is equal to X per unit volt into kV base volt by kV base new. Since we are calculating with respect to LT side, we are substituting LT side value as 11 and corresponding base. Okay. So next thing is we have to calculate for transmission line. So it's given as X per unit for X per unit is equal to X actual by X base. So how to calculate this base value? So we have to calculate X base as kV base squared by MVA base. Okay. So kV base square for this line. So it is respect to section 2. Section 2, what's your kV base? It is 140. So it is 140 square divided by MVA basis. Throughout the problem it is base as 10. So it is 10. So what's your answer? It is 1960 ohms. Correct. So now substitute here, actual base value is J100 divided by base value is 1960. So for transmission line, the value is J0.051 per unit. So the unit is per unit. So next you have to calculate for transformer T2. So next for transformer T2, right? So T2 is over here. So you have to calculate with respect to HT side or LT side. So it's up to you. So you have to calculate. So exponent volt for the transformer is 0.15 into kV base volt. It's given in the problem whether it's with respect to HT side or LT side. If you are considering as LT side, it is 12. The kV base new for section 3 is 13.12 kV square into MVA base new is given in the problem as 10 divided by MVA base volt is given in the problem here also as 10. So the transformer T2 will give you J0.25 per unit. This is X per unit new for transformer T2. So next thing is you have to calculate for motor. So same way, X per unit new is equal to X per unit volt for motor, that is for the 0.1 into kV base volt for here, it is 11. kV base new for section 3 is 13.12 square into MVA base new is 15 MVA, that is 10 MVA. Old is given in the problem 15. So for motor, if you substitute, you will get J 0.6146 per unit. So now we have calculated reactance per new for the whole network, right from generator, transformer T1, then transmission line, followed by transformer 2, then motor. So what's the thing? You have to plot the overall values by drawing the single line diagram, that is with the equivalent circuit. Okay, how to draw this? For generator, this is the equivalent reactance of generator, then transformer 1, then transmission line, then transformer 2, then motor. Motor and generator we have to represent in a similar fashion. Okay, so this is generator, this is motor, this is T1, this is T2, and this is transmission line. So we have calculated the values. Just represent for transformer T2 J 0.125. For motor is J 0.614. Then for generator it's J 0.56. Okay. Then for transformer T1 it is J 0.168 per unit. Then transmission line it is J 0.051. So this is your equivalent reactance diagram for the given network. So this is my given network and this is the equivalent reactance diagram. So just we have a short recap. What we have to do? We have to go with the reactance diagram, and from that we have to identify the section wherever the voltage getting changes. We have to calculate the new kV base at that section. So for that we have the formula kV base new on LT side of transformer 1 is equal to kV base on LT side of transformer 1 into voltage rating on HT side by voltage rating on LT side. Similarly, you have to calculate for section 3, and for calculating the reactance new for each component, the basic formula is X per unit new is equal to X per unit volt into kV base volt by kV base new into MVA base new by MVA base volt. So the old values and all it is given in the problem, whereas new values and all you have to calculate based on the data. So this is the reactance diagram calculation for the given power system network. Thank you. So next problem. So for example, for the same reactance diagram calculation, if it is given with transformer rating with 3 single phase transformer, or else it's given with star delta connection or neutral grounding. So how to calculate the reactance diagram? So the thing is here transformer T2 we are considering it as 3 single phase. So MVA is given as 100 MVA. So it is 3 into 100, 300 MVA. For that we have the transformer connection as star to delta. So we have to convert the line value. So it is 127 into root 3. And secondary side is delta. So line value is equal to phase value is same. So we are consider the transformer connection. and here it is delta to star, so there is no change. Similarly, we have motor M1 and motor M2. So here it is given with the MVA value, kV value and reactance value. So how to calculate the same value? That is the reactance value for the given network. So first, what's our first step? We have to calculate kV base on each section. So wherever the transformer rating or voltage rating getting changed, so there you have to calculate kV base. So for example, here it is section 1. Here it is section 2 and here it is section 3. So generally, generated side MVA will be taking it as base MVA for whole problem. So base MVA as 300 it will be considered throughout the problem. So first thing is we will be calculating kV base on section 1, kV base new. So what's the formula? kV base new on LT side is equal to kV base new on HT side into kV voltage rating of LT of T1 divided by voltage rating of HT side of T1. So you have to substitute here. What's your kV base new on HT side? So straight away you can calculate for transformer T1. How to calculate your reactance X per unit new, X per unit volt into kV base new by kV base volt square into MVA base new by MVA base volt. So what's your X per unit volt for transformer T1? So it is given as J.1 into kV base volt is 20, kV base new also is 20 squared into MVA base new. MVA base new is 300, MVA base volt is 350. So what's your answer? J 0.08 7 per unit. So this is for transformer T1. Similarly, I have to calculate for transformer transmission line. So what's our value given? It is given as J.5 ohms. So the line reactance is given as J 0.5 ohms per kilometer. So if it is given for the whole length, so line length is 64 kilometers, so 0.5 into 64, so it will give you J32 ohms. So that is your total reactance for the line. So it's nothing but your actual. What's the formula for base? X per unit nu is equal to actual by Z base. Okay, so what is Z base? Z base is given by kV base squared by MVA base. So kV base squared for HT side of transformer T2 is 230 by MVA base is 300. So you will be getting 176.3 ohms. So substitute this ZB over here. So now X per unit nu is equal to X actual is we have calculated J32 divided by 176.3. So what's your new value? 0.1815 per unit. Okay, so now we have to calculate for transformer T2. Transformer T2. So same formula, X per unit nu equal to X per unit volt of transformer T2 is 10%. So J 0.1 into kV base volt by kV base nu. kV base volt for transformer T2 is 120, 220 divided by X per kV base nu for this is 230 whole square into MVA base nu. MVA base nu is 300 divided by MVA base volt for transformer T2 is 300. So 300 will get cancelled. If you simplify this, transformer T2 will get J 0.09 per unit. This is for transformer T2. Right? So next, for motor M1, in the similar fashion you have to calculate and you have to draw the diagram. For motor M1, same fashion X per unit mu is equal to X per unit volt for motor 1. So it is J 0.2 into kV base volt. kV base volt for this section is 13.2 kV divided by 13.8 whole square into MVA base nu by MVA base volt. Nu is 300, volt is 200. Okay, so if you simplify this, you will get J 0.27 per unit. Similarly, for motor M2, X per unit nu is equal to, for motor X per unit volt is 20%, so J 0.2 into kV base volt by nu. kV base volt is 13.2 divided by 13.8 whole square into MVA base nu is 300 divided by volt is 100. So if you simplify this, you will get J 0.54 per unit. So now we have found out the reactance value for each network. So now we have to draw the signalling diagram. This is for generator and this is for transformer, this is for transmission line and this is for transformer 2, and here I have two motors. So this is, both are connected in parallel. This is M1, M2, T2, T1 transmission line generator. So whatever we have calculated, the reactance per unit values you have to plot in the equivalent reactance diagram. Thank you.